Welcome everybody to our 87th Reading Online Sports Economics Seminar. We are very pleased to have Stefan Szymanski speaking today, and he will be speaking on productivity and cricket, test match cricket, productivity and temperature. Before we hand over to Stefan, there's a couple of announcements to make. The first is that one that Pete Goose has sent a message around the list about. I will post in the chat as well, and that is that there is a special issue of the Journal of Economics, Race and Policy, and there's a call for papers for the special issue on the economics of race, gender and sports. And so I will post that in the chat, and please do look out for that. There is abstracts for the special issue deadline of March the 1st, so it's quite soon, but then for the actual submissions, it's much later in the year in September, and the special issue is expected to appear in 2023. It would be remiss of us not to note there have been some tumultuous events in the global economy, although around the world, in the last few days. And there was a conference that was due to be taking place in St. Petersburg in a few months' time, in May, organised by Dimitri. And Dimitri is here, and I'm happy to hand over to Dimitri, who's going to send us a message about the Football Economics Conference in May.
James, thank you for giving me a word. Dear colleagues, last year I invited all of you to St. Petersburg to participate in the Football Economics Conference. Unfortunately, at that time, no one could imagine what is going to happen, and I'm no longer recommend you to come. In these circumstances, it seems that the only appropriate decision is to move the conference online. We're still committed to disseminate the knowledge of sports economics. And as a researcher, I do not like generalizations, but it seems that at HSC University, at New Economics School, no one supports what is going on in Ukraine now. Having said this, we have still 26 excellent submissions, 4 plenary talks, and I really hope that we will be able to organize the conference at the dates at the end of May. If you have any questions regarding the conference, please don't hesitate to ask me. We will still proceed with our regular procedures of peer review, and I hope that participation in the conference will be useful for our younger colleagues, since they will be able to get some feedback from more senior guys and peers. Thank you.
Thanks very much, Dimitri. And so that's the St. Petersburg Football Economics Conference, which will move online this year, in May. And without wishing to hold up Stefan any further, I will now hand over to Stefan. Just a quick admin message. Please do keep yourself muted on microphones. And if you want to ask Stefan questions as he's going along, please do raise your hands and I will then interrupt him. All yours, Stefan.
Thanks, James, and thank you very much, Dimitri, for those words. Actually, and that's very. I think we all support you in what you're trying to do, and I think all of us would say if there's anything we can do to support you, then please say, because these are terrible times, and we must support the people who are doing the right thing. Okay, so without moving on from that. Sadly, my subject seems somewhat trivial, I have to say, in the light of what's going on in the world, but nonetheless, I shall push on anyway and talk to you this morning about productivity and temperature, the case of test match cricket. I hope you can all see my slides now. I'm trying to go full screen. Okay, so I think one thing I should probably say is that, I'm trying to see what is the smallest audience you can get for a Roses seminar. Last time I attempted it with a paper on ad valorem taxes, which was pretty successful in minimizing the audience. And so today, cricket, surely this should be a really winning strategy. So, but I think you'll find something about this interesting. I hope you will. And certainly, I think I'm trying in this presentation, and I'd be interested to hear your feedback of whether I succeed. I'm trying to also use this to address that perennial problem we have in writing about sports, is how do you make a point that is of interest to a general economics audience if you happen not to be interested in cricket? And amazingly enough, not everybody is interested in cricket. So the motivation then I want to use is this idea of temperature and productivity. And I've got this quote here from a paper in the American Economic Journal from 2012, which talks about the relationship between productivity and temperature. And by and large, there's a long-standing view that low-income countries tend to be the problems of poverty and productivity in low-income countries is in some ways connected to temperature, and that can be in very pejorative, very insulting ways about people being lazy in the heat and so forth. And certainly issues about culture being associated with climatic conditions. And this is an example of a paper where the authors tried to look at the relationship between temperature and productivity. And what they concluded was that if you look at temperature shocks, so random fluctuations in temperature, they argue that they could have substantial effects on productivity, but only in poor countries. And you can see there at the bottom, it says a rise of 1 degree centigrade in temperature in a given year reduces economic growth by 1.3% on average. So really a very substantial effect, which leads me to sort of say, well, what do we know about the effect of temperature on human behavior? And there is a somewhat substantial literature on what you might call, what are called thermal stressors in the literature. And I hope you like this little diagram. I didn't draw this diagram. It's actually from the paper itself. So it looks like a logo for a bank or something. But what it actually shows is the idea of what the empirical evidence shows about the relationship between performance and temperature, which is the idea that there is a range of temperatures within which humans can perform more or less at full capacity, but that as temperatures rise above a certain threshold or fall below a certain threshold, then performance starts to deteriorate. So here, the range here that they cite in this paper is 11 degrees centigrade to 29.4 degrees centigrade as being the sort of temperatures of which performance starts to deteriorate, and otherwise within that range, people can perform normally at full capacity. And there's quite a lot. This is just one example. There's quite a lot of papers along these lines. But some of these papers are sort of quite entertaining in a way. And I can give you an example here of Galloway and Morn in 1997. This paper looked at exercise duration and looked at temperatures. And they said, they found that exercise capacity, people could exercise at full capacity in the range of somewhere between 4 degrees and 21 degrees centigrade, and that beyond these temperatures, below or above these temperatures, you started to see a reduction in capacity. And if you stop to think about it, I mean, yes, certainly growing up in England, where 4 degrees centigrade is not such a weird temperature, and 10 degrees is a very common temperature, then I can understand how that would work for me. But once you start to think about, well, how would that work for someone who was born and raised in the tropics, it's sort of laughable to think that it's going to wait until 4 degrees centigrade before you start to see a deterioration in performance. It could happen well before that if you're used to temperatures more like 30 degrees as a regular norm. And and we know about heat stress and typically, heat stress affecting athletes from temperate climates. But there was just a recent example last week when Honduras was playing the USA. The US chose to play it, I think it was in Columbus, Ohio, where the temperature was minus 17 degrees centigrade. And funnily enough, the Honduras players were struggling to play at this temperature. Of course, it's way beyond anything that they would be used to in their day-to-day lives. So this is why I think Test match cricket starts to become interesting as a way to think about the effect of temperature on productivity. So here in this map in red, you can see the countries where Test match cricket is played. I'm going to explain for those who don't know what Test match cricket exactly is in a minute. But just to get into the sense of the geography, I've drawn on the equator there, and you can see actually in South America at Guyana, they play cricket in Guyana, Test cricket in Guyana, and you can see they're actually part of Guyana is on the equator itself. And you can see looking east, you can see that Sri Lanka is not that far from the equator either, and they are also players at Test match cricket. Whilst obviously at the other extreme, you can see England at the top there. England plays Test match cricket and it's quite a long way north. And in fact, if you look down to New Zealand, that's quite a long way south. Certainly when you get to the tip of South Island, you're quite a long way south of the equator. And even somewhere like Melbourne in Australia, on the southern tip of Australia, you're not that close to the equator. So so what that means is there's quite a lot of variation in temperatures of people who people who play Test match cricket have people who play Test match cricket can come from quite varied temperature backgrounds, climatic backgrounds, and that's the idea that I'm going to try to exploit in this paper. So there are the highest level of cricket. Test match cricket is typically thought of as the highest level of Test match cricket. And indeed, up until recently, there were only 10 national teams in the world that played Test match cricket. So it's a game played by national teams, not by clubs. So to play for a Test match nation, or for a Test match team, you have to be a national of that nation. So you can see here a list of the 10 Test match nations, and 2 more have been added. And apologies to anyone from listening from Afghanistan or Ireland, who are the 2 nations that have been recently added in the last few years. So far they've actually played very few Test matches, so I didn't include them in the data. So these Test match cricket goes back, in fact, was first started to be played in the 1880s, so it has quite a long history. And you can see here the different climates of those nations, and what the figures here are the average daily temperatures on days when Test matches have been played in this country, going back as far as the records allow. And this is taken from the Global Historical Climatology Network, which is online and where you can actually just download this sort of daily data where the records exist. And indeed, for most of these cases, these records exist a long way back, even into the 19th century. And what you can see here is that I've broken the nations down into 3 groups. At the top, you have climates that I would describe as hot, Sri Lanka, the West Indies. And if you're not familiar with this, what is the West Indies? That's not perhaps a member of the United Nations you ever heard of. West Indies is actually play as a collection of predominantly Caribbean islands that are independent nations, such as Jamaica, Trinidad and Tobago, Antigua, also Guyana and South America as well. So they have played as a coalition again, from the very beginning, they first played international games back in 1926. And so they've retained this identity. Otherwise, these are all associated with sovereign countries. So you've got Sri Lanka, the West Indies, essentially the Caribbean islands, and Bangladesh, where average temperatures are around 25 centigrade or above. Then you have the moderate group, and perhaps some people might be surprised at this. Remember, this is just based on the days on which Test match cricket have been played historically. And you can see India, Pakistan, Australia, South Africa, and Zimbabwe all in a range average temperature between 20 and 23 degrees centigrade. Although you can also see the standard deviation. There's quite a lot of deviation, particularly, for example, look at this Pakistan. It's very large. And then you have at the bottom, you have the cold nations, and they are basically New Zealand and England, where, again, you can see temperatures ranging between 16 and 17 degrees centigrade, with actually a relatively small standard deviation. So you can see there the differences in these temperatures, and where I am now in Michigan, the temperature, I believe, outside is about -5 degrees. And you think about that is sort of really too cold to go outside. You really don't want to spend any time outside if you can. If it went up by 10 degrees to 5 degrees centigrade, 5 degrees above zero, then it might not be shirt sleeve weather, but you'd be quite comfortable going out in a hat and coat. So the difference between the cold of New Zealand and England and the heat of Sri Lanka, West Indies, and Bangladesh really is a very substantial gap. It's a difference between being potentially, depending on where you're from, to being quite comfortable and being quite uncomfortable.
Stefan, can I interrupt you?
Yeah.
Subo had a question.
Yeah, sorry, Stefan. So I was a bit surprised to see Bangladesh in hot country and India in moderate, because I am from Calcutta, which is just next to Bangladesh. And I have worked in Chennai, which is as hot as Sri Lanka. So are they taking average temperature of the whole country or the particular city where the test is being played?
Yeah, so the data is based on the city in which the game was played and the temperatures on the days on which games were played. So that's why, yeah, I think you're right. I mean, it looks sort of surprising and you wouldn't think this is true, but these are the historical average, and it may have things to do with scheduling, time of year. So this is not necessarily a general reflection on the climate overall, but certainly although, yeah, you might say that the gap between India and Bangladesh here is in the average is not actually that great. If you think about it, it's just 2 degrees, and that's not as substantial as say the 10-degree range between England and Sri Lanka, for example.
And just a comment. The other one is it might be good to mention that all the things that we're talking about are all male. I don't think you're having female test cricket data yet. So, and you know, the Chang and Kite paper where they show that the temperature and productivity is very different for male and female.
That's a very good point. And actually, we do have test match data for women, although it's not as extensive. And I haven't done that analysis, but I think you're right. I think that would be a great follow-up to this to think about whether you see the same effects that I'm going to show you when we look at women's cricket. So thank you. That's a very good point.
And Johan also had his hand up for a moment there.
Hi, Stefan. This might help if you get this again in future, but if you look at the standard deviations of like your Indias and your Pakistans, that might kind of overcome that issue that you've got quite a small mean, but given the country's quite vast and games are played throughout the country, that might be helping out in kind of that explanation that you might have some temperatures which are higher up in the 27s, 28s, and others are quite low. So I'm just wondering if that's something you can maybe use in future when you write this up.
Yeah, I mean, you're saying these standard deviations are quite large, and you know that so they cover the range of the across the countries, right?
exactly relatively. So if you look at the standard deviation for Pakistan, for India, which is 4.4 and Bangladesh 3.5, you're probably going to have a good overlap there, where the Chennai and the Bangladesh thing, you're probably going to have similar temperatures. So
yeah. What I found, the one thing that, one of the reasons why I sort of for drawing attention to this, and this is not really central to my analysis, but one of the things that struck me was that certainly raised in England, you know, one is tempted to think of India as being always and everywhere very hot, and actually you can get quite cold, or not very cold, perhaps, well, you can get very cold days in India depending on where you go, but also you can get quite moderate temperate days depending on time of year and where you happen to be. And I think that was just one of the things that struck me about this, is that we all come with a certain amount of climate prejudice, I think, and I think this just serves to highlight that. Although again, I don't think anything really rests on that, although we can discuss that as we progress. So here we go. So what do you need to know about Test cricket as a game in order to understand this paper? To which the answer is very, very little, right? What you need to know, it's the bat and a ball game, and you know, essentially it's a contest between the batters, the people who are trying to hit the ball, and the bowlers, the people who are throwing the ball, what in baseball you would call the pitcher. And there's all sorts of rules and regulations and traditions and behavioral patterns that you could talk about in this, but none of them really are very significant in terms of understanding this paper. What you need to understand is the team that scores the most runs is the one that wins, as for example in baseball. And the other thing you need to understand is that in the game of Test match cricket, and this can vary according to the format of cricket you play, and here we're only talking about Test match cricket, is that each team has 20 wickets, which you can think of as resources which you can spend in the pursuit of runs. And they are equivalent to what you call an out in baseball. And so a way to think about it is you use your wickets in order to accumulate runs and accumulate the largest total, and the team with the largest total wins. And of course, there are lots of other details about this, but those details are not necessarily central to understanding or even significant in understanding the paper. The other thing to understand, particularly for baseball people whom this can often seem quite strange and confusing, is that runs are very, very easy to come by in cricket, unlike in baseball, where they're very, very difficult to come by. And outs are very, very scarce. Your 20 outs in a game that each out is really something you don't want to, is really a high cost to the team, whereas outs in baseball aren't really an issue, broadly speaking. And of course, the final thing and the most important thing for this paper to understand, and probably the thing that actually most people would know about cricket, and if they've never been interested in it, is that this is a game that can last fully 5 days. So the same game is played on different days, and that's the key idea that I want to exploit in this paper. So each day in cricket consists of 3 2-hour sessions of play. So you start around 10 o'clock in the morning, and you will finish after you've had lunch and tea at about 6 o'clock in the evening. And of course, that's what makes cricket also one of the most beautiful games in the world. How many games stop for lunch and tea? Anyway, so the point is that we've got these different days on which the game is being played, and that's what I want to exploit in my analysis.
Stefan?
Yes.
Got a question from Jose for you.
Yeah, Jose.
Yeah, nice, Stefan. So I was wondering why temperature may have an effect here. So is it like a game where you're exhausted at the end of the day, or not, or?
Sorry, I didn't quite catch that. Sorry, my sound's not very good here.
So yeah, so I was wondering why temperature might have an effect on performance. So in the sense that, is it a game where you are exhausted at the end of the day, or you have to run a lot, or?
Yeah, a good question. So So, right. So one of the things, so people often associate cricket with not much action. So they think it's rather, you stand around and how could anybody get tired in that? But that's not really right. And so if I asked you to stand in a field for 6 hours a day for 5 days in 30-degree heat, I think you'd struggle. I think you'd find that quite exhausting. Likewise, if I asked you to stand in a 10-degree temperature, I think you'd find that quite exhausting. So there is actually a fatiguing effect that can be associated with being exposed to these temperatures over a very long period of time. And actually, there is some research on the effect of temperature on bodily performance based on very high temperatures, because sometimes these games are played in temperatures that are very high relative to people's norms, and so that's one reason why you'd expect this to be an effect. So, interestingly, the people who are exerting the most energy in this, the most sort of kinetic energy, are the bowlers. As you can see, that looks rather strenuous, but they're not necessarily the players who are actually suffering the biggest effects due to temperature, and we'll talk about that. I'll talk about that in a little bit. So it's a good point, and one we might want to come back to as we progress.
So can you go full screen also, or?
Oh, sorry, you can't see the full screen?
No, it's we see also the slides on the left, but okay, it's.
I don't know why that is.
But okay, it's a detail. So, but then I was wondering also if what matters is also the variation, right? So more than the average, because you are usually playing in England, and then you have to go to India playing a cricket match, and then you're affected because of the difference in averages. That's the idea.
Yes, perfect, and that's exactly what I'm going to do. So I'm going to look at the individual variations and look at individual days and think about how the temperature effects could be measured in that. And of course, that's why it's important to me that I can exploit this variation, this aspect of the game that it's played over 5 days. And so temperature can vary from day to day within the game. I'm just going to see if I can share my screen again. I'm not sure why make it a full screen. Sorry.
You go full screen first and then share.
Yeah, that's what I'm just doing now. So there. Do you have the full screen now?
It's full screen now.
Great. Thanks. Thanks.
Sorry
about that.
Before you carry on though, Stefan, Alex has got a question for you.
Yep.
So do you have some theoretical model from contest theory? How the heat should affect performance, for example?
Yeah. So I started with that, right? So right at the beginning, I said there's this research about the effect of temperature on performance, and that rather simple diagram here, which shows based on thermal conditions, is that these heat stressors have an effect at the extreme. So there are a number of papers about what kind of effects these are having. So there can be effects on people's reaction times, for example. That can be important. And there's also an effect on cognitive ability. So people can start to again, you can imagine extreme cold or extreme heat, you start to lose your ability to pay attention. And of course, then at the great extremes, there's like these death zones, which are mentioned here, where the body starts to shut down. The core body temperature rises too high or too low, and you get those extremes. And certainly, in terms of the heat, there have been cases in cricket and other and then actually in other sports where these thermal stresses have actually led to serious injury And I think in some cases in soccer, actually, people have died. I don't, and in American football, I mean, there are also cases where that's happened. I don't know of any particular case in cricket, but it's certainly your ability to play the game is being significantly reduced by exposure to these. Can be exposed to very high temperatures, but it also actually suggests that that's going to be true at very low temperatures.
But I mean, just one question, last one. This is an interactive game, so the heat should affect both teams in the same way, or what exactly?
Right. So that's that's the point that I'm trying to exploit here. It depends on what you're used to. So I'm coming from England. I'm used to temperatures of 10 degrees centigrade, and they don't bother me too much. If you're from Sri Lanka and you're used to something more like 30 degrees centigrade, then 10 degrees can be quite unpleasant. Likewise, if you ask me to play cricket in 30 degrees centigrade, then I would find that somewhat challenging because I'm just not used to that temperature. So bear in mind that these are all players of a national team. So these are not like soccer players who are moving all around the world playing for different clubs, getting used to different conditions. These are players who typically play regularly in their own country, and then for a limited time they visit another country to play them at Test cricket. And so at that point, the visiting team can be exposed to dramatic extremes of temperature relative to their experience. So again, imagine a Sri Lankan team coming to play in England, and it's a very cold day in England, or an English team going to play in Sri Lanka, and it's a very hot day in Sri Lanka. That's the kind of effect. So one side, there's an asymmetry here. One side is going to be at an advantage and the other at a disadvantage based on their experience. And I'm going to go into more detail about that right now, actually, if that's okay.
Stefan, one more question from Jorge for you.
Sure.
Yes, hi. So I'm assuming that cricket is not as globalized as soccer may be, because, for example, what has happened down here in Colombia, we used to play, or we normally play home in Barranquilla, which is 30 degrees and 90% humidity. But that was very good years ago when all of our players played in the domestic league. But now 98% of them play out in Europe mostly, or the United States, and that is playing against us. So what you just said means that most cricket players still play in their domestic leagues, or they are really used to whatever temperature, local temperature they have. Is it like that?
Yeah. So as I say, these are the countries in red where cricket is played, where Test cricket is played. So it's a very small subset of the global population. Obviously significantly boosted by the presence of over 1 billion Indians. But the other point is that, yes, predominantly, most of these players in my data set will have played almost all of their cricket in their home country. They won't have had significant international experience. There are a couple of exceptions to that, which we can talk about further. So a number of these international players will have had some chance to play in England other than playing Test cricket. Limited, but some opportunity. And then today, the biggest cricket competition in the world today is actually something called the Indian Premier League, which is not Test cricket at all, but where many of the top Test cricket players will go and play. And they will go and play in India in this competition each year. And so they'll give them some opportunity to get experience of playing in India. But the issue is that the competition only lasts less than 2 months. So it's a sort of limited opportunity, and only not all of the Test players get to do this. Only a limited number of them do. All right. Okay, so as I said, there are the questions that people were asking, I think, illustrate the sort of motivation for this paper is that there are significant differences in the temperature in which games are played, and differences in the temperatures between what the visiting team is accustomed to and what the home team is accustomed to. And within the same game, there are significant variations in temperatures between days. So we can assess the performance of teams on different days within the same game, conditional on the temperature on that day. And so you can see here something like 10% of the overall variation could be attributed to within game variations based on our data. So looking at, we have over, in the data, there's over 6,000 days worth of games where we have observations of temperature, and that relates to just under 2,000 games. So you can just see that not every games don't necessarily last the full 5 days. So you can see there the average is actually below 5 days play. So here's an example of 2 examples of the temperature differences that we observe. So there's the and so these are kernel density estimates. Again, these are estimates of the daily temperature on the days of which test match games were played in each country at the ground or in the city in which the game was being played. So based on the city location. And you can see here between England and the West Indies, there is almost no overlap at all in terms of the days on which games are played, in terms of the temperatures. And likewise, when we compare New Zealand and Sri Lanka, again, almost zero overlap. So England and New Zealand are very similar, and Sri Lanka and West Indies are very different from England and New Zealand and likewise Sri Lanka. Of course, I mean, that also tells you that for a New Zealander playing in England, it's almost the same as playing at home in terms of temperature. And likewise, for a Sri Lankan playing in the West Indies, it's more or less the same as playing at home. So there are differences between countries, but then there are some where there are a lot of similarities. If we look at some of the other nations, so again, comparing Australia and South Africa and India with Pakistan, again, we see a lot of similarities in their experiences. So in the temperatures, so the distributions look different. So what we have here is a data set in which sometimes you'd expect temperature could play a role, and sometimes it wouldn't. It's not that it's going to play a big role in the outcome of every game. It's going to be a little bit contingent on the circumstances. So I want to say a little bit, just before going into looking at the data in more detail, I want to say a little bit about why acclimatizing is going to be difficult. And again, this sort of goes to the question that someone was asking. So I have 2 pictures here, playing cricket in Barbados and playing cricket in Durham in the north of England. And so the point I'm trying to make is that cricket at 30 degrees centigrade is going to be a very different experience from cricket at 8 degrees centigrade. Most of the players who play Test cricket will have developed their game in national domestic club games, which they play. And typically, very few of these players will have had experience of playing in foreign countries outside of playing Test matches themselves. And the 2 exceptions I mentioned are English county cricket, which has historically always employed a small number of elite players. So if you think of a touring team coming from Australia of, say, 20 players, then probably at least half a dozen of them, maybe a quarter of the players, will have had some experience of playing maybe in an English summer. So there is some limited experience, but many of the players, it will be their first, they will only have visited the UK to play Test cricket. And of course, many of those players may only get to do so once anyway. They may only go on one tour. Remember, so for example, England and Australia, which is the rivalry between England and Australia, is sort of one of the biggest historical rivalries in cricket. They've been playing since the 1880s, but they only play essentially once every 2 years. So there's a tour every 2 years. So it's not that it's not even an annual competition. So again, the exposure is relatively limited. And there is a calendar of play for Test match nations where essentially the teams circulate around the globe playing. And so for example, England was in Australia just around the turn of the year, was somewhat convincingly annihilated by the Australians, which is not an unusual experience for English cricket teams in Australia. And the English cricket team is right now is in the West Indies, so they're playing there. Then they'll play there, and then they'll come back to England in the English summer and play games. I'm not sure who's touring England this year. I think it might be, I forget now, it might be India is visiting again, but they'll play a series of games in the summer, and so you've got this sort of progression around the world. So amongst the 10 test match nations, it takes a while to get around to everybody, and so again that limits the opportunity to acquire experience and to acclimatize to temperatures in different countries. And one thing to say that's very important about this is that home advantage really matters in cricket. So what you have here is the win-loss records at home and away of the test match nations, and you can see essentially the win-loss ratios go from just below 2 to over 4 for comparing the home and away performance. And so home advantage really is very important in playing these games. And that's obviously not, by no means is that just about temperature. It's about a whole range of factors which climatic, cultural, and so on, which is affecting these results. You may also know that a lot of jokes based around the fact that a 5-day game of cricket can actually end in a draw or a tie, and that's very common as well. But I'm just ignoring that here for this. I think about a third of the games are actually drawn. But here I'm just focusing on the wins and the losses. So again, home advantage really matters. So the performance measure that I use in this paper for each team is the runs per wicket scored on a particular day. So, and again, to think about what this means, in baseball, the runs scored per out are almost perfectly correlated, because in a game of baseball, the number of outs on each team is very similar, if not identical. So in a 9 innings game, there are 27 outs. If the game goes to the bottom of the 9th innings, then you will end up with you're likely to end up with both teams ending up with 27 outs at the end of the game. The most extreme case that you can have, I think, in baseball is when the home team has won by the end of the 9th inning of the visiting team. So in which case you would have 27 outs for the visiting team and 24 outs for the home team, and that's the biggest gap that you can have. And so, which means that the runs per out and runs scored are going to be very highly correlated with each other, and runs scored are very highly correlated with wins. And the difference in Test cricket is that the number of outs can be significantly different over a game between the two teams. And I've put out on the right-hand side the example of a rather dismal game in this, at least for an Englishman, a rather dismal game played from the series in Australia that I just mentioned, where England were completely annihilated by the Australians. It required 1 innings by the Australians to score 267 runs, without losing 10 wickets in total, and the English, with their 20 wickets, with twice as many wickets, were unable to accumulate even that total. And so that was a complete rout of the England team. So you can see there that that's why runs per wicket are actually going to be in some ways a better measure of performance than just looking at runs scored. And indeed, runs per wicket are very highly correlated with wins in Test match cricket. So
Stefan,
Sorry, yep, there's a question.
Yeah. So how do you define this performance measure for 10 wickets win? Say I didn't lose any wicket, but I win in the fourth innings.
Oh, so I add 1. So I add 1 to the wickets total, which of course is right because you have 11 players. So again, without going into the technicalities of cricket, but Sumo, I'm sure you appreciate that as an adjustment, right? Good, good question. Thanks. So here I start off by looking at the impact of the weather of the daily totals of runs per wicket. So this is the aggregate for both teams combined. So we're not looking at the competition between the teams. We're just looking at the total effect. And what you can see here is that the top line shows you the impact of rain on runs per wicket, and the second row tells you the impact of temperature on runs per wicket. So of course, this is a rate. So one thing that, I mean, a lot of the time the game will stop if there is rain, because you can't play cricket in the rain really. And so you might say, well, then how is it having a negative impact on runs per wicket? Well, bear in mind that this is daily rainfall. So this is rain that fell at any point in the day. And it's not uncommon in cricket to have an interruption of the game. So you may not be able to get the full 6 hours of play into a day, but you may be able to get, say, 3 hours of play of a game in a day when there is a rain interruption. But what this shows is that on days when it rains, even if they are able to play, the rain is having a negative effect on runs per wicket. And you've got the 4 columns relate to 4 different versions here. We have the first column is the entire data set. The second column is just games played after 1980. The third column relates to the first innings. Now, again, without going into the technicalities of Test match cricket, there are 2 innings per team. So effectively, you get two attempts, two lots of 10 wickets to try to accumulate runs. And the first attempt is usually determinative in terms of the outcome of the game. So the outcome of a game is very highly correlated with the team performance in the first innings. So in some ways, measuring performance, just restricting oneself to the first innings is in some ways is often one of the most instructive ways of looking at it. And the final column is just looking at the England games. England has played more Test match cricket than anybody else in the world. But by quite some margins compared to most of the Test match nations, and so it's potentially interesting to look at England, which is obviously a very rainy place as well. And interestingly, the rain effect on runs per wicket is statistically insignificant, although it's still negative and looks at the same order of magnitude roughly as the other estimates. It's just not particularly precise. So why would rain affect runs per wicket? Well, essentially, in the contest between batting and bowling, this is suggesting that the rain actually relatively helps the bowlers, makes it harder to bat overall, which is sort of an interesting finding. And then the second row, the focus of this study, of course, is that temperature is actually make it easier to accumulate runs per wicket. So in general, higher temperatures make it are advantageous for performance, and this may have to do is that cold generally makes everything more sluggish, can affect reaction times, and so it may well be that batters struggle more in cold temperatures on average, regardless of their background and experience. In cold temperatures, and therefore there's an advantage in terms of the aggregates for runs per wicket. And then just to mention the form variables here, this is a variable, and I experimented with a number of variations on this, but this is the runs per wicket scored of the home team in the previous 15 days of Test match cricket, which is at least three previous games and possibly more, and the same thing for the away team. And what you can see is that the form of the teams on either the home team or the away team has much of an effect on the runs per wicket. And in some ways, that's what you'd expect, because this is the aggregate. Why should the form of one team or the other have a particular impact on the aggregate of runs per wicket scored? I mean, if the home team is in good form and the away team is in bad form, then the home team might score more runs per wicket, but it doesn't necessarily anything about what the aggregate of runs per wicket should be. So that seems to make some sense.
Stefan?
Yeah.
Alex has got a question.
Hey, Alex.
So so before you told us that temperature has some kind of quadratic form on performance, right?
Well, I haven't got. That's the next slide, actually.
Okay, sorry then.
Is that okay?
Yeah.
That's good. No, thank you. That's almost like I put you in the audience to put me on cue for the next slide, which is what this is about is the advantage to a team based on temperature. So how do I measure temperature advantage, which I think was the question essentially Alex was going to ask or was asking. So, and this is, as you suggest, is essentially going to be a quadratic effect. So what I do is, so you have to take into account two things, I think. One is, what is the temperature difference between the two countries that are playing? So again, what is the temperature difference at which Test match cricket is played? So what I do here is take the average of the, I measure the difference, I take the average temperature difference between the two countries. And that's what I've highlighted in green here. And then here in this example, I've given an example where a day in England where the temperature is particularly low, so that the temperature difference here in red between the temperature in England and the temperature in Sri Lanka, which is the hypothetical visiting team, that temperature difference is going to be very large. So what I'm suggesting here is that this is a case, if on a cold day in England, it's going to be a significant advantage for the England players. It might be cold for the English, so they might not be particularly comfortable in the cold, but it's going to be much more uncomfortable for the Sri Lankans, who come from a climate where the temperature is on average much higher. So you think about how this temperature advantage is going to work. So firstly, if the teams come from countries where Test match cricket tends to be played at similar temperatures, then there will be no temperature advantage. The temperature might affect aggregate performance, but it won't affect relative performance because there's no temperature advantage. So, for example, if you look at, I showed you before the example of, say, South Africa and Australia, where Test cricket tends to be played at roughly the same temperatures, then in those games, there's likely to be very little temperature advantage to either side. But in games played between England and Sri Lanka, there could be a temperature advantage, could be quite significant. The other thing to say is that it's not here. In general, we'd expect that the temperature advantage is going to work in favor of the home team, but that's not always necessarily going to be true. It has been known, it's pretty unusual, but it has been known for England to have very hot days. And on a very hot day in England, a Sri Lankan visiting team is going to think like they're at home, and the English are going to think, my God, what's going on? So and that would be captured in this as well. So the temperature advantage could be in favor of the visiting team in some cases. Although, of course, not surprising, generally the temperature advantage works in favor of the home team. So based on that measure, here are the kernel density estimates for the temperature advantage that I've just described to you by country, and you can see a number of different cases. So again, you see Australia; these are in alphabetical order. Australia, there's tends to be relatively little temperature advantage, but when you look at Bangladesh, you see this sort of bimodal story. So in most days, there's, again, like Australia, there's relatively little. It's really centered at close to zero. But then you've just got this second peak here at around a value of about 100, where there's a significant temperature advantage. And that's going to be typically visiting teams that come from relatively cold regions who are playing in Bangladesh. Then you have England, where you have this sort of long tail of distribution. It's sort of, you can see it's sort of bimodal, but you basically got a significant number of games with this temperature advantage of which can actually go well above 100. And the one I like, I think, most, as you can see the different patterns here, but the West Indies, again, has this very, very clear bimodal pattern where they have this, generally speaking, they have a bit of a temperature advantage, but they have this huge advantage in some limited number of cases. And again, to give an example, a temperature advantage of 100 would roughly be the difference between the temperature on an average day in England and Sri Lanka. So that gives you some idea of what sort of games where we're seeing this impact. Okay, so here are some regressions which look at the effect of the temperature advantage on the success of the teams. So the first column is the home win probability, and just shows that home win probability is increasing in the runs per wicket of the home team and decreasing in the runs per wicket of the visiting team. So just to show that this runs per wicket is significantly, the performance of each team is significantly related to the outcome of the game, which is what you should see. And then the second column shows you that the home win probability is increasing in the home team temperature advantage. So that suggests that the temperature advantage can indeed play a significant role. Then the third column shows you the effect of the home team temperature advantage on the runs per wicket of the home team. And there it's insignificant. So if you think about the runs per wicket, this is the batting performance of the home team. And the batting performance of the home team is unaffected by the temperature, which suggests that the bowlers of the visiting team are not affected by the temperature differences. They can adjust. It's the fourth column, the runs per wicket of the visiting team, that seems to be significantly affected by the home team temperature advantage. So it seems to be the batters who stand out there all day are suffering some impairment because of the impact of the temperature advantage. And the last column shows that there is indeed a significant difference between the runs per wicket of the home team and the visiting team. I'm aware that I'm sort of running out of time here, so I want to. This
quite a bit.
Sorry, yep.
I was going to say you've been interrupted quite a bit, Stefan. So feel free to run over. But before you do that, there's two questions coming in. First from Jed, and then Subo. Okay. Go ahead, please. Jed, you might be on mute.
Can you hear me now?
Yep.
Yeah.
Okay, perfect. I'm really interested how you're going to sort of disentangle the effect of temperatures on, say, the batsmen themselves, just because it's warmer and it maybe that makes it easier to have reaction times or whatever the case may be, and the effect, say, of the temperature on pitch conditions. I know, for example, New Zealand cricketers do really well in England because the temperature is very similar and the pitches are very similar, whereas New Zealand cricketers often struggle in India because it's hotter, but also the pitches are something that they're less familiar with. So, yeah, how do you think about those two effects of temperature?
Well, that's where I think a great point. And of course, there are enormous differences for these players depending on which country they're used to. I think that's a really important point. And I think the answer is that the variation here is day to day. So if it was if it was just about conditions in general, then those conditions are largely the same from day to day. It's the temperature which is varying one day to the next, which is driving these differences. And I think that's why the temperature per se, just looking at the daily temperature, is what is the effect. So, I think that's a core to my identification strategy, if you will.
Okay,
there was
great.
another question.
So yes, Stefan. So I'm a bit confused about concluding that okay, it's the batsmen who are or batters who are suffering, not the bowlers, because in the end it's a dual problem. It's really hard to disentangle. It might be that the actual reason is the home bowlers are actually doing better than better in the home condition of the change temperature, and that is affecting the away batters. It might be that there is no difference in terms of batting performance. It's just the bowlers are doing differently.
Well, so the whole principle of the temperature advantage is that the home team players are more accustomed to those temperatures. So I mean, you'd have to reverse the reasoning, wouldn't you, to say that the home team bowlers could be more affected by conditions than the away team bowlers of the home conditions, which would seem to be a really strange sort of way to think about it. So so I'm struggling to see how that would work.
No. What I wanted to say is, so this home team temperature advantage, it's I'm looking at column 3 and 4. So home team runs per wicket and away team runs per wicket in this one, right?
Yeah. So
we are interpreting
column
that
3
and 4, like if we are compare home team and away team, column 3 and 4. So you're saying that this negative and significant effect of home team temperature advantage on away team runs per wicket. So you're saying that means the away team batters cannot adjust with the temperature advantage, right? That's the way you're interpreting. And I can interpret it in a way such that the home team bowlers are actually more accustomed, and that's why they are doing better. That is affecting away team runs per wicket. So what I'm saying is, what we can say from these two regressions is the overall performance of the away team is getting bad. But is it because their batters cannot adjust, or is it because home team bowlers are doing better? We cannot say from here.
So right. So let's put it this way: in the contest between batsman and bowler, there is the temperature advantage exerts no influence in when it comes to the home team batting. But in the contest between batsman and bowler, there is a significant temperature advantage for the home team in relation to the away team's batting. So the away team. So yes, so the bowlers are doing better when the temperature advantage is going their way, and the batsmen are doing the the domestic bowlers are doing better when the temperature advantage works their way, and the foreign visiting batsmen are doing worse. Right? And so you're saying, well, maybe that's because the domestic bowlers do better when the temperature advantage is in their way, and what I'm saying is yes, that's an interpretation, but it doesn't sound very plausible to me, because on the grounds of why would that be an advantage to the home team? It seems much more plausible that it's an advantage it's a disadvantage. It's the fact that the batsmen are struggling in these conditions. Does that make sense?
I was thinking more about, if you know your temperature and all those things, you can use saliva, and I don't want to go to detail. So, but my point was
that we can have
that
a discussion afterwards.
Yeah, sure. I don't want to take up time.
I'd certainly like to hear you articulate the point. Maybe if you sort of sent me an email or something, and then that would help. But I could clarify, and I get the Okay, but it is an interesting point.
And Stefan, just before you carry on, do you want to finish off and then have some time for discussion, or would you? There's a couple more questions, but we can park them and have a Q&A at the end.
Well, I've only got 2 more slides, so
Okay.
what do you think?
I don't mind. It's up to you. Do you want to take the questions now and then finish off, or finish off then take the questions?
Well, let me finish off just in case that I'm actually going to answer some of the questions next. So I think that since I haven't got far to go, that probably might be the best way. So as I said, these are the main regression results of the paper. Again, you can see along the top, I've listed the first column is the full data set, and the remaining columns are various restrictions on the data set. And what this shows is, so the first column again shows the impact of rain on runs per wicket, and the one thing that's interesting about this, which I don't really have a good explanation for, is actually the rain affects the home team. The rain seems to affect the visiting team, not the home team runs per wicket. So you can see the home team interaction actually seems to cancel out the effect of rain on runs per wicket, which is an interesting finding. But as I say, my main result is this result here on the batting advantage for the away team, and the interaction of away team and temperature advantage and home team batting temperature advantage. And you can see here that the temperature advantage is having, in each case, a statistically significant negative effect on away team batting runs per wicket, but no statistically significant effect on home team runs per wicket. And again, subject to the discussion I was just having with Subo, I interpret this to say that the visiting batsmen are struggling in the conditions, but the visiting bowlers are not necessarily struggling in the conditions, which I think is an interesting point. Just to say briefly that you can see that the form variables below are all statistically significant, as you'd expect, and have the signs that you would expect. So the logic of this, it seems to me, is the temperature advantage adversely affects the batting of the visiting team, but has no effect on the batting of the home team, while the rain negatively affects the performance of the visiting team. And in terms of the economic significance of this, well, again, take over the whole data. The average runs per wicket of the home team is 35.9, and runs per wicket of the visiting team is 31.7. Of course, the home teams have a higher runs per wicket on average because home teams tend to be much more successful. And so a temperature advantage of 100, which we talked about, sort of the typical advantage that you'd expect in a game between England and Sri Lanka, on typical days, temperature on those countries, that's worth about between 0.66 and 1.5 runs per wicket. And to give you a sense of the importance of that, around 4% of games were settled by a run per wicket margin of less than 1.5. So this sort of brings me to my conclusions. The temperature advantage affects team performance in Test cricket. The main effect occurs when the temperature advantage is large. The effect is mainly observed when there's a large difference between the average temperatures at which games are played in the home and away team nations. And the effect could plausibly affect outcomes in about 4% of games, which is a small percentage. But again, given the data, I wouldn't expect it to be a very large percentage. It matters. It's a factor. It's by no means the biggest factor in determining the outcomes of Test cricket, but it seems to suggest, but also it's this nice symmetry. It's not just about people struggling to compete in hot climates. It's also about the difficulty of competing in cold climates. And just to the final slide for this, the whole point of this, of course, is to advertise my book, which is just about to come out with Tim Wigmore, Crickonomics. This is basically one of the chapters in the book. And of course, there will be much more to interest you and become inspired to be a follower of Test cricket in future, as I'm sure will occur. Thank you very much. So,
thank you
please, more
very
questions.
much, Stefan. Thank you very much. I'm conscious that actually, I thought Jose's hand was a hand from his previous question, but he's kept it for a very long time. So the order of the questions will go first to Jose, then Jorge, then Johan, and then Dimitri for questions. So Jose.
Yeah, so congrats, nice paper, and I'd like to see the book to learn about cricket. So yeah, it's also nice that temperature affects the team performance. But the theory you mentioned is also the individual level. So I was wondering if it's possible to go at the individual level for the regression as well, and because I guess that some players are playing in a specific for like as you said, bowler, for example, and so they're playing different games in different continents, and so I was wondering if it could be possible to use this variation.
So in principle, yes. So in each game, I have the identity of each player, so I could measure that. The difficulty is somehow it's often difficult to so identifying the daily performance of each player would be the difficulty. So I can measure the aggregate, so how many runs were scored and how many wickets fell on a given day. But say what can happen is a player can be batting on 2 different days. So he can score 10 runs on one day, then still be playing the next day and score 20 runs and then get out. And that's data I don't have, so I don't have the timing of those games. And with modern databases, it's probably going to become possible to do that. But bear in mind, some of my games are going back to the 1880s, and so collecting that data would be difficult. So in principle, yes. In practice, I think it's pretty tricky. Be interesting to do that.
Yeah, because again, the theory, like the hum shape that you have, is really at the individual level, right? So I don't know how it works at the team level.
No, it's interesting. One could certainly think about doing it for more recent games. And one of the things is that, I mean, people talk about Test cricket dying. So you couldn't do this. The type of cricket they play in the Indian Premier League, this version called T20 cricket, which takes basically you can finish a game in 3 hours. It's much quicker. It's much more like a normal professional team sport. You couldn't do any of this with that, I think, because you don't have the same variations from day to day.
Is it me, James? Okay.
Yeah, you go on.
Sorry for not turning on the camera. I'm at my office and I don't have a camera yet. And thank you very much, because I did live in England when I was a kid and I never understood why games lasted days. This is the first time in my life I actually understand why they last more than 2-3 days. I just didn't get that. Now I am based in Colombia and we are in the tropics, so I tend to think of temperatures a lot in terms of humidity. And of course, you're also thinking about games on differences in between, the home and away teams. But having said that, maybe especially when you think about games in the tropics near the equator, the hour of the day matters a lot. And think about what we did here in Barranquilla when we could play at 3 p.m. where humidity was really high, while the visitors were trying to make the game to be at 6 or in the night when the humidity is much lower, not necessarily temperature. So that may matter. And I had written in the chat your interaction, what might be capturing if tropics really matter a lot in your data set is that when it rains, even you don't play when it rains, humidity really goes up a lot. And so the home team may be more used to that humidity after raining. And so that's why you get that positive effect of the interaction. Congratulations on the book.
Thank you. And yeah, those are really great points. And I think humidity is a really interesting issue. And so again, coming from England, we have this sort of typical view of England. It rains all the time, and it doesn't just rain. Nowhere else rains, and it's certainly true that England is a very rainy place. But as you point out, there's an awful lot of rain in the tropics, and in fact, most of these countries that play Test cricket actually have quite a lot of rain. So it's sort of a fairly omnipresent feature of cricket. And I think you're right, humidity probably plays a role. And I think there are two things to say about that. So one of the things, and nobody's raised this point, but I thought somebody would raise it. There's been a lot of discussion about cricket about the way in which the ball can move in flight. It's what's called swing. So the ball can actually swing away from the batter or into the batter based on the way that the bowler throws it. And that is often associated with atmospheric conditions. So I thought somebody would say, well, isn't this all just atmospheric conditions? Because this is a very widely held view. If you talk to people in cricket, they'll say, oh, well, the temperature on the day really matters, and the climate really affects the way the game is played. And a lot of engineers have done studies on this and have actually debunked this and said it's not. It really isn't to do that. Although there is a phenomenon known as turbulent airflow, which does affect the way the ball is delivered. And as far as I understand it, turbulent airflow is not directly related to temperature. So I wanted to say that. Maybe no one here actually cared about that issue, but it is something that I thought that people would mention. And more generally, I would love to be able to control for humidity in the data. But the problem is that, as far as I can tell, the climate data that doesn't actually have daily humidity measures going back this far, and that's why I don't have it in. And I'm sure you're right. I'm sure humidity matters, and to the extent that temperature is correlated with rain and temperature are correlated with humidity, that may well be part of the explanation of the rain effect that you're talking about here.
Great, thank you, Jorge. And then next is Johan.
Hi, Stefan. So yes, I was going to bring in swing bowling, so that's what I was actually going to move on to. So yeah, depending what school of thought you are, whether it's temperature that's correlated, which makes the ground, the convection currents and creates that turbulent air towards the wicket and all those kind of things, and depending which school you believe of, it's overcast clouds and all that. We can maybe discuss this till the cows come home. So,
and we should, of course, I hope everybody understands, we should spend much more time talking about cricket. So that's just a general point I hope you all take away from this morning.
So yeah, I was going to say, is it actually temperature, or is it more kind of generic conditions that we're looking at here in terms of the... Okay, I buy the temperature argument in terms that you can tie people out of the field. If you're stood out there and you're not getting wickets and you're making a bowler chase all the way down to the boundary all the time, then when he's bowling, he's going to be inferior and all this kind of stuff. A couple of trivial points. The first thing is, does the coin toss matter here? Because you get the weather forecast for the next 4 or 5 days, and the coin toss is completely random. And you can then start to say, okay, well, I'm going to put them in now because I know it's going to be freezing cold on a miserable day in Headingley. I'm going to get the away team batting first. And when it kind of burns through for 11 minutes of sunshine, hopefully we'll be into bat. So the coin toss may matter here. I'm also thinking about a series, because what you've got, I'm assuming, is you've got test match series between 5 different games. Does this persist? So when we get to, say, the 4th or the 5th test, do teams kind of acclimatise a little bit better in terms of temperature? And then there's a final trivial point here as well for you, which kind of links to what Jed was saying as well about pitches. Now, if I'm going to be playing in India, I know I'm not going to win because if I'm English, because English, we just don't breed spinners, and that's kind of initial conditions. And there's this kind of, if you can't spin, you won't win. I think that's the motto that they have over there in India. So in terms of how the pitches are working and the initial conditions of youngsters, unless they've been born elsewhere, is that going to have an impact? So I don't know how you control for that. Maybe you say how many spinners we have in the team, how many pace bowlers, and I don't know. It's just, but I think that might just give something there which might kind of help explain things, or at least control it so you get that temperature effects. Sorry everybody for boring you about all these kind of funny, interesting things.
And yes, so and everybody else should go away and start reading up and try and make sure you understand these points, and there'll be tests later, right? So, so I mean, in terms of your first, but seriously, you only raised really good points. These are important issues in terms of understanding these results. So, firstly, in terms of the, I mean, again, it comes back to the identification strategy. The culture of England and Sri Lanka or New Zealand and the West Indies are very different, and these will no doubt have huge effects on the ability of players to perform in different regions. But the identification here is through the daily variation in temperature. The culture doesn't change from day to day, the temperature does. So that's effectively what I'm arguing enables me to identify this as the effect of temperature. The coin toss, interestingly, there's quite a lot of research saying that coin tosses don't make any difference in cricket, which is an interesting thing. So I didn't include the coin toss, and you know, possible that research could be overturned, but and I think it actually probably the current thinking at least is that it doesn't matter. So which is counterintuitive. You'd think it would, given your example, but apparently no, it doesn't. The third one was the issue about the over time whether teams acclimatize over a series, because these series of games can be up to 5 games and they can last for this can go on for 2 months, so there's time to acclimatize. And what I would have expected, if that were true, then what I would have expected to find that when I remember I talked about my form variable based on the last 15 days of test match cricket that the team has played, their runs per wicket over the last 15 days. Well, I experimented with extending that and up to 45 days of experience. So that would cover at least 9 previous games, including, so fully encompassing a series where you were coming to the end of a series, and the temperatures variables were still significant. But I could perhaps look at the end of a series. I mean, part of the difficulty is that some of these series are quite long and some of them are quite short, and that's probably a difficulty in controlling for that. But interesting points. Thanks.
Thanks, Johan. And now Dimitri.
Stefan, my question is about the betting market efficiency. At the end, is this temperature advantage included in the betting market?
That's a great question, and we may have to wait 100 years to answer that question, because bear in mind this is data going back to 1883, and I don't have the betting odds from 1883. I mean, in fact, probably you can only find betting odds for cricket going back to probably the early 2000s. Now, that said, there's quite a lot of test match cricket, and I haven't seen any. I think actually what you're suggesting is really a separate paper. I think there's a whole separate paper about betting efficiency in cricket, and I think that's a great paper, and I would be very happy to co-author it with you, Dimitri. That sounds like a good project we could start on.
Thanks.
Great, thank you, Dimitri. Ian Gregory-Smith.
Hi, Stefan. Can you hear me?
Yeah, hi, Ian.
Yeah, hi. Have you thought about weighting your temperature advantage variable to either penalise hot or cold temperatures more? So I would have thought that playing in the cool in England, you can mitigate that by putting on a jumper, rubbing your hands, getting warm, moving around a bit, and you're all right after a little bit. But if you're in Australia, you're at risk of heat stroke, like it's chalk and cheese in terms of how uncomfortable you're going to be in those extremes. I mean, we're never playing in -5 or -10. It's only just cool weather. So have you thought about penalising the sort of super extreme heat a little bit more?
So again, I think you should talk to some people from tropical countries about what it's like to play cricket in England at 10 degrees centigrade. I think you find actually that the idea that you just put another jumper on, I think they would push back on that concept. So I do think it's genuinely difficult by this. So one way is, so actually the version of the temperature advantage I found that works best in the regression. I've experimented with a number of different variants, but actually I exclude all temperature advantage measures below, or I said all advantages below 100 to 0. So I only look at the extremes. I think the interesting question, which I haven't really settled, is whether there's an asymmetry here. And my impression is that there isn't. that actually it's symmetric. But I think that's the question that I should maybe look at a bit more, is to find a test of symmetry here, because I think it's a valid point you're raising about whether it's more easy to adapt in one direction than the other. I think that's a valid point.
Okay, thanks, Ian. Any more questions and comments? We've got a couple of minutes left in the scheduled time.
Well, then we have a couple of minutes for people to just admire the backgrounds.
When's it going to be available to order?
You can order it now on Amazon and or your local bookseller. You should probably go to your local bookseller. That's probably a better thing to do. And it's the publication date. I think the final publication is in May at the moment. So I think it's sort of, which is roughly the start of the English cricket season. So that's surprisingly.
Time. Okay, well, thank you very much, everybody. Thank you, Stefan, for a really interesting talk. Thank you for a lot of interesting discussion. And we will break for the weekend, and then we will return next week when we will have Anna-Katharina Pikos from Leibniz University in Hanover. Different but stable gender-specific competitive behavior across age. And the setting for this paper is 9-pin bowling, which I didn't even know existed. And so it's definitely the first 9-pin bowling sport economics paper in the series. So join us next Friday for that. And in the meantime, I hope you all have a great weekend.
Thanks, everybody. Thank you.